In this unit, we're reviewing various algebra topics, and for this video, we want to look at linear equations. We're going to start with the most simple kind, and that is a linear equation in one variable. So my definition, a linear equation in one variable, I'll use x, is an equation that can be written in the form ax plus b equals 0. A and b can be any real number with one exception. The a cannot be 0 because I need an x term or I don't have an algebraic equation. Okay, now it says it can be written in the form ax plus b equals 0. So it doesn't mean that it's given to me in that form. For example, if I have 2x equals 5, that's not in the right form, but I could subtract the 5 on both sides and that would give me 2x minus 5 equals 0. So indeed, that would be a linear equation in one variable because it has just that x term and a constant term. So as long as it can simplify to that, it's considered a linear equation in one variable. Now let's take a look at this little video here that I put together that explains kind of the basic idea about solving equations.
To help us understand the process of solving equations, let's consider putting up and putting away our Christmas tree. So first, we put up the tree. We either get it from the lot or get it out of the box and assemble it. The next thing we're going to do is add our decorations. And then finally, we'll top it with our tree topper. After we've enjoyed it and it's time to put it away, we're going to reverse this process, doing everything in the reverse order. So we remove the topper, then we take down the decorations, and finally, we remove the tree. Okay, so when I'm thinking about equations, I want to think about it in the same way. If I've added something to my x, I'm going to undo that by subtracting. If there's subtraction, x minus something, I'm going to undo that by adding. Also, we could have other operations like multiplications. If it's 2 times x, I would undo multiplying by dividing. And lastly, if I have x divided by 2, I would undo that by multiplication.
Okay, so that's the basics. Let's take a look at the overall strategy. So most of the time we're going to be given an equation that's a little bit more complicated than just x plus or minus something or times or divided by something. So our goal, our first step would be to simplify both sides. If there are parentheses, we would distribute. If there are like terms, we would combine them. So we want to end up with one x and one constant at most on each side. Then I'm going to go ahead and get all the constants to one side, left or right, does not matter, and then the variables to the other side, all right? So x is on one side, numbers on the other side. And we're going to isolate that variable, which means we're going to undo the operation, that's usually division, and solve our thing. Then we're going to check our solution. All right, the best way sometimes to learn is to practice. So here are a couple problems. Let's take a look at these. I'm going to get my pen out. And my first one here is 3x minus 8 equals 13. There's nothing to simplify on either side. So instead, what I'm going to do is I'm going to try to get back to that x. Now remember the Christmas tree idea. You work the furthest away to the closest. So I work, put the topper away, then the decorations, then I put the tree away. So I first need to get rid of this 8 because it's subtraction. I undo it by adding. And I'm going to get 3x equals 21. I like to do my problems vertically and keep everything in order. That way I don't lose terms, I don't miss signs, and that kind of thing. It's just very organized. So now I see that I have 3 times x. So undoing that multiplication means I need to do division. My final answer here is going to be then 7, or at least that's what I believe. So last step, and this is an important step, especially when you're doing a high stakes assessment like a quiz or a test or a final, you want to check your answer, right? So checking our answer means taking the value that we put for, or found for x into the original equation where that x was. So for this one, it looks like that. 3 times the 7 minus 8 equals 13. So I'm checking this to see, I'm going to put a question mark. So 3 times 7 is 21 minus 8, and I'm again asking, is that 13? Yeah, I think 13 equals 13 is a true equation, so I'm going to circle that and say that is the correct answer. All right, now why don't you hit pause and try the next problem. Okay, so I'm hoping you tried this one on your own. It is a little bit different because in this case, we actually have a 4 minus 5x. So the x is in a different position and we have to think carefully about what that 4 is doing. It's a positive 4 and it's being actually added to that negative 5x. So in this case, I'm not going to look at the sign behind the number. I'm going to look at what kind of number I'm dealing with here. It is a positive 4, so I'm going to subtract 4 from both sides, and that's going to give me negative 5x. Notice I did carry down the sign in front of the 5x term, equals, and this would be just 35. Now I'm going to divide like we did in the last problem. You always divide by exactly the same thing as you're multiplying by, which in this case is a negative 5. So I'm going to divide both sides by negative 5. All right, there. And then negative divided by negative gives me my x, perfect. And a positive divided by a negative, oh, I believe that is a negative answer. Now I'm going to leave it to you to check this one and check out the other videos for a few more complicated examples.